Okay, welcome to the deep dive. And today we are diving into something that's pretty fundamental when it comes to keeping digital environments safe.
That's right.
We're talking about SIEM.
Yes.
Now, you asked us to unpack what these security information and event management tools are all about, and that's our mission for you today. We want to sort of give you the inside track on a really fundamental piece of the cybersecurity puzzle,
Right.
cutting through the noise to what really matters.
Okay. So we've gone ahead and we've sifted through quite a bit of, details on SIEM deployment, what makes it tick, under the hood, even how to figure out the capacity of these systems. The goal is to give you a clear understanding of what SIEM is, how it actually works in practice to identify threats, and why it's such a cornerstone of modern security. And of course, all while keeping it digestible.
Right.
We don't want to dive into the deep end of, technical jargon too much. We want to make it something that you can understand and apply.
Exactly. And to give everyone a little bit of context, you might remember our earlier conversation where we really dug into cyber attack frameworks.
Yeah.
Things like INRI, ATT and CK, the cyber kill chain, the diamond model, all that good stuff.
Those are the good ones.
Yeah, and those really helped us understand how attackers think and operate.
Right.
But today, we're kind of flipping the script and looking at key defensive technology, the SIEM. It's kind of a natural next step in understanding how organizations actively defend themselves.
Makes sense.
So let's unpack this.
Yeah.
In its simplest form, what is a SIEM?
Right. So at its heart, SIEM stands for Security Information and Event Management. It's basically a software solution that acts as a central intelligence hub for security-related data. And imagine it kind of like as this highly skilled security analyst that never sleeps, constantly collecting and examining these logs, these digital footprints of activity.
Yeah.
From a whole range of sources across an organization's entire IT landscape. So this includes things like your firewalls, servers, applications, databases, even cloud services.
Yeah.
The SIEM takes this mountain of raw data, analyzes it for these suspicious patterns, and then flags potential security incidents.
So it's like taking all the individual log files, which, on their own might not tell you much,
Right.
and then connecting all of them to see the bigger picture.
Exactly.
Which could be, kind of a risky picture potentially.
Yeah, and that's the key, right? It's connecting the dots. Because often these individual events might seem benign on their own,
Right.
but when you put them together, you start to see the bigger picture.
Yeah.
And that's where the SIEM comes in.
So why is understanding this so important for, somebody who's following this field?
Well, there's a few really critical reasons. I think first and foremost, it enables real-time threat detection. Because it's continuously processing this incoming data stream, it can actually identify malicious activity as it's unfolding.
Okay.
Which gives security teams vital early warning and, the time to react. Second, it provides that centralized log management capability. Imagine trying to make sense of, millions of log entries scattered across dozens of different systems.
Yeah, that sounds like a nightmare.
It can be a nightmare.
Yeah.
A SIEM pulls all that information into one unified platform.
Okay.
Makes it searchable, manageable, and ultimately useful.
So that sounds like it could really transform, like a chaotic data sprawl into something actionable.
Precisely. Yeah, it gives you that single pane of glass into your security posture. And that centralized view, it's absolutely essential for effective incident response. When a security event does occur, having all the relevant historical and real-time information consolidated in one place significantly speeds up investigation and containment efforts.
So it really streamlines things.
Yeah, it streamlines things.
Makes it much faster.
Exactly. You don't want to be scrambling trying to find the right log files when you're in the middle of an incident.
Yeah, it sounds very overwhelming.
Exactly. But beyond just threat detection, SIEM is also crucial for compliance.
Okay.
A lot of these regulatory standards, things like SOC2, ISO 27001, PCI DSS, they mandate robust logging and monitoring capabilities.
Right.
And a SIEM is a key technology for meeting those requirements.
So it's not just about catching the bad guys.
Right.
It's also about demonstrating good security practices to auditors and regulators.
It's about having that audit trail.
Yeah.
Proving that you're doing what you say you're doing.
Okay, so there's an accountability aspect to it as well.
Absolutely. And finally, a properly configured SIEM can dramatically reduce the noise of false alarms.
Okay.
By correlating events from multiple sources. It can distinguish between those benign anomalies and genuine threats. For instance, A single failed login attempt might be a user mistyping their password. But what if you see multiple failed attempts, followed by a successful login from a geographically unusual location?
Yeah.
That's where the correlation logic kicks in. That's where the SIM really shines.
Right. Let's really illustrate that for people who are listening. Imagine you log into your company's email from your office in London.
Okay, sounds normal.
Seems perfectly normal, right?
Yep.
But then just a few minutes later,
Huh.
the SIM detects another successful login to your same account, but originating from a server in, say, Nigeria.
Right. So on their own, a login from London and a login from Nigeria.
Yeah.
They're just individual events in different log files. But the SIM sees both of those events, recognizes they pertain to the same user account. Notes that incredibly short time frame between two geographically distant locations. That correlation engine flags this as highly suspicious, a strong indicator of potential account compromise, and immediately triggers an alert for the security team to investigate. And that's the real value proposition of a SIEM. Its ability to connect these seemingly unrelated pieces of information to reveal a potentially serious security incident. That individual logs alone wouldn't expose.
That's a really great example.
Yeah, it helps to kind of put it into perspective.
Yeah, and paints a very clear picture.
Right.
So we understand what a SIEM is and why it's so critical, but how do organizations actually implement one?
Right.
What are the different ways a SIEM can be deployed within their infrastructure?
Yeah, so there are three main deployment strategies.
Okay.
The first is an on-premises SIEM.
Okay.
As the name suggests, this involves installing the SIEM software and storing all the collected log data on servers that the organization owns and manages directly within their own physical infrastructure.
Okay.
This typically requires a significant upfront investment in hardware, storage capacity, and ongoing maintenance by their internal IT team.
So essentially, the organization is building and maintaining its own dedicated security data analysis platform.
That's right. Yeah, they're taking on the full responsibility.
Who typically opts for this approach?
So organizations with particularly stringent compliance requirements and very strict data security policies. They often gravitate towards on-premises deployments. They might be subject to regulations that mandate keeping all sensitive data within their direct physical control and network perimeter.
Okay.
This is definitely something to consider depending on the types of organizations or industries you're interested in.
Right. What's the alternative to having all that infrastructure in-house?
Well, the second deployment model is a cloud-based SIEM.
Okay.
In this scenario, the entire SIEM platform, both the software and the data storage, is hosted by a third-party provider in their cloud infrastructure. The organization simply sends its logs to the provider's cloud environment.
Okay.
And all the analysis, correlation, and storage happens there.
So what are the major advantages of going with a cloud-based SIEM?
So, scalability and cost-effectiveness are significant benefits.
Okay.
Cloud-based SIEMs can easily handle fluctuating volumes of log data without requiring the organization to make additional hardware investments. They also often come with lower upfront costs and reduced operational overhead. As the provider manages the underlying infrastructure, patching, and updates, this flexibility and lower barrier to entry can be especially attractive for growing businesses or those with more dynamic and distributed IT environments.
That sounds considerably less hands-on.
It is, yeah.
From the organization's perspective.
They're essentially outsourcing that management to the cloud provider.
Is there a way to get kind of the benefits of both approaches?
Yes, there is. The third option is a hybrid SIEM deployment.
Okay.
This is a combination of both on-premises and cloud-based components. For instance, an organization might choose to keep logs from their most sensitive internal systems on their own premises, while leveraging the cloud for the scalability and advanced analytics capabilities for other data sources.
So it's aiming for the best of both worlds in terms of control and flexibility.
Right. Hybrid deployments allow organizations to tailor their SIEM architecture to meet specific security requirements for different types of data, while still taking advantage of the cloud scalability and cost advantages where it makes sense for them. This model is frequently adopted by organizations that have strict regulatory mandates for certain data categories, but also recognize the operational benefits of cloud-based services for other aspects of their security monitoring.
Okay, so we've covered the where of SIEM deployment.
Right.
Now let's delve into the what's inside.
Okay.
What are the essential components that make a SIEM actually function?
Right. So a SIEM system is a complex but well-structured ecosystem with several key components working together. The first crucial element is the log collection agent. These are like the data gatherers, if you will. They're responsible for collecting logs from all the diverse sources we've discussed: firewalls, servers, applications, databases, endpoint devices, cloud services. Virtually anything that generates security-relevant logs.
Okay.
These agents collect the raw data in its native format and securely transmit it to the SIEM for processing. And just for those who have a bit more technical background, it's worth noting that there are different types of agents.
Okay.
Agent-based software installed on the source system, agentless collection methods that pull logs remotely, each with their own trade-offs in terms of the data they can collect and the management overhead involved.
So they're kind of the frontline data feeds
Yeah, that's a good way to put it.
for the security system, constantly bringing in information.
Right.
What happens to all that raw data once it arrives at the SIEM?
So that leads us to the second component, log storage and indexing.
Okay.
A SIEM can ingest massive volumes of data,
Yeah.
terabytes, even petabytes, over time. So it needs a highly efficient way to store and organize this information
Right.
for rapid searching and analysis. This involves storing the logs in a structured format within a scalable database
Okay.
and creating indexes. Think of it like the index in the back of a book.
Okay.
It allows security analysts to quickly locate specific events or patterns during investigations, without having to sift through the entire raw data set. The underlying database technology and the indexing strategies employed are critical for ensuring the SIEM can perform timely investigations.
Uh-huh.
And you might hear terms like schema on write versus schema on read,
Okay.
which represent different approaches to structuring this data.
Makes sense. You can't effectively investigate an incident if the relevant data is buried in an unsearchable mountain of logs.
Exactly.
What's the next critical step in the process?
So next up is the event correlation engine,
Okay.
often considered the core intelligence of the SIEM.
Okay.
It's the component that analyzes the normalized and indexed logs,
Uh-huh.
looking for relationships and patterns between different events. It uses a complex set of predefined rules, statistical models, and sometimes even machine learning algorithms to identify suspicious activity and generate security alerts. And a key insight here is the constant challenge of tuning these correlation rules effectively. Too broad, and you get overwhelmed with false positives.
Right.
Too narrow, and you might miss subtle but genuine attacks.
Okay, so there's a balance there.
It's a constant balancing act to get it just right.
So this is where the S actually starts to connect at those
Yeah.
seemingly isolated events and identify a potential threat.
That's exactly right.
Yeah. Okay.
It's all about connecting the dots.
Yeah.
And seeing those patterns that would otherwise be missed.
Okay. And then what?
So following the correlation engine, we have the dashboard and reporting component.
Okay.
This provides that visual interface for security teams to monitor the overall security posture of their environment
Uh-huh.
and review the alerts generated by the correlation engine. So imagine a centralized security console displaying key metrics, real-time event feeds, and interactive dashboards that give analysts a clear and actionable overview of what's happening within their digital landscape.
That sounds crucial for maintaining situational awareness
It is.
and understanding the flow of security events.
That's exactly right, yeah.
Okay. And is there anything else?
Yeah. So another indispensable component is threat intelligence integration.
Okay.
Modern SIEMs have the ability to connect with external sources of threat intelligence.
Okay.
These feeds contain up-to-date information about known malicious actors, compromised IP addresses, malicious domains, other indicators of compromise, or IOCs. Examples of IOCs include specific malware file hashes
Okay.
or the network addresses of known command and control servers used by attackers. By continuously comparing the internal logs against this external threat intelligence, the SIEM can identify potential attacks that match known patterns of malicious activity, even if those specific events haven't triggered any internal correlation rules yet.
So it's like having a constantly updated watch list
Ex-
of known bad actors and their tactics that the system can automatically check against.
Right, it's like having a bouncer at the door of your network,
I like that.
checking IDs against a list of known troublemakers.
Yeah.
And finally, we have the alerting and response system.
Okay.
So when the SIEM detects a suspicious event, through correlation or a match with threat intelligence, this component is responsible for notifying the appropriate security personnel. This can range from sending email or SMS notifications
Okay.
to integrating with other security tools such as ticketing systems or even automated response platforms to trigger predefined actions in response to certain types of incidents.
So like automatically isolating a compromised computer from the network.
In some more advanced implementations, yes. To really solidify how these components work together, let's go back to our failed login scenario.
Okay.
Imagine an employee's laptop experiences a burst of failed login attempts within a short time frame.
Okay.
On its own, this could just be a user who's forgotten their password. However, if the SIEM then detects a successful login from that same laptop immediately following the failed attempts, the correlation engine recognizes this sequence of events as a potential brute force attack, where an attacker may have finally guessed the correct password. Because the organization has integrated threat intelligence,
Okay.
the SIEM might also check the source IP address of the successful login against known malicious IP ranges. If a match is found, this further strengthens the suspicion.
Okay.
The alerting system then notifies the security team, providing them with the details of the affected endpoint, the time of the events, and the potential threat identified. This illustrates how the various components, log collection, storage, correlation, threat intelligence, and alerting, work in concert to detect and flag a potentially serious security incident.
Yeah, that's a great example. That really clarifies it for me.
God, I'm glad.
It shows how all the different parts of a SIEM work together to provide that really comprehensive security picture.
It's all about that holistic view, and that's what the SIEM brings to the table.
Now, you mentioned earlier that EPS, events per second, is a critical metric for SIEM sizing.
Yeah.
Could you elaborate on what EPS is and why it's so important for understanding a SIEM's capacity?
Absolutely. So EPS, or events per second, it's really a fundamental metric when it comes to planning, deploying, even budgeting for a SIEM. It essentially represents the average number of security-related events that a SIEM system is capable of processing every single second without experiencing performance degradation or missing critical data. Understanding your organization's anticipated EPS is absolutely vital because it directly dictates the required processing power, memory, storage throughput, and overall infrastructure resources that your SIEM will need. And it also has a significant impact on the cost of the SIEM solution.
Okay, so this is a big deal.
It is a big deal.
If your SIEM isn't adequately sized to handle the typical volume of logs your environment generates, it can become overwhelmed, leading to delayed processing, missed alerts, and ultimately a reduced security posture.
Exactly. It's like trying to pour a large river through a small pipe.
Yeah.
It will eventually back up and overflow.
That makes perfect sense.
Yeah, and you don't want that happening with your security data.
So it's about ensuring the SIEM has sufficient processing horsepower and data handling capacity.
That's right.
To keep up with the real-time flow of security data.
You got it.
How do you actually go about calculating what your organization's EPS might be?
The basic formula for calculating EPS is quite straightforward.
Okay.
You take the estimated total volume of security-relevant logs your organization generates in a typical day, and divide it by the total number of seconds in a day, which is 86,400.
Okay.
So the formula is EPS equals total log volume per day divided by 86,400.
Okay, that's a relatively simple calculation.
It is.
But what are the key factors that actually influence that total daily log volume?
Right, so several factors contribute to that overall EPS. Firstly, the sheer number of devices and systems that are configured to send logs to the SIEM is a primary driver. Obviously, the more servers, network devices, workstations, cloud services, and applications you have, the greater the potential volume of log data generated.
Makes sense.
Secondly, the log generation rate per individual device or system can vary dramatically. Some systems are inherently more chatty than others, meaning they produce a higher volume of log entries for every unit of time. For example, a heavily utilized public-facing web server will likely generate significantly more logs than a relatively idle internal file server. Thirdly, the verbosity or level of detail in the logs being collected also plays a crucial role. Are you collecting just basic connection logs, or are you capturing more detailed audit trails? The more detail you capture, the larger the log volume. And finally, the types of security events being logged will influence the volume. Certain types of security events, like detailed firewall session logs or application debug logs, it can be significantly larger in size than simple system event logs.
So it's a combination of how many devices are reporting, how frequently they're generating logs, and the level of detail being captured in those logs.
Exactly.
Can you walk us through a quick example of how an organization might calculate their estimated EPS?
Certainly, let's say a mid-sized organization estimates that
Yes, right.
across all of its critical systems,
Mm-hmm.
it generates approximately 100 million security-relevant log events per day.
Okay.
To calculate their average EPS, they would take that total daily log volume, 100 million, and divide it by the number of seconds in a day, which is 86,400.
Uh-huh.
Performing that calculation. 100 million divided by 86,400 gives us an approximate average EPS of 11,157.
Okay.
This means that, on average, this organization's SIEM solution needs to be capable of processing around 1,157 security events every second. And it's vital that the SIEM platform they select has the capacity to handle this sustained rate of events, with some buffer for peak periods, to ensure effective real-time monitoring and analysis without becoming overwhelmed, and potentially missing critical security alerts. Understanding this helps them choose a SIEM solution with the appropriate performance characteristics, and also provides a basis for future capacity planning as their environment grows.
That's a really clear and practical way to understand the importance of EPS in SIEM planning.
It's one of those key metrics that you really need to get a handle on
Yeah.
early in the process.
Now, the market for SIEM tools is quite extensive.
It is.
Could you give us kind of a landscape overview of some of
Sure.
the key players and what generally distinguishes them in the market?
Absolutely. So the SIEM market is indeed quite crowded
Okay.
and continues to evolve rapidly. Several key vendors have established themselves as leaders in this space.
Uh-huh.
One of the long-standing leaders is Splunk Enterprise Security. Splunk is widely recognized for its highly flexible data ingestion capabilities, powerful search and analytics engine, and its robust machine learning features, which are particularly valuable for detecting advanced and novel threats that don't necessarily conform to traditional rule-based detection. Their architecture is more of a data lake approach,
Oh.
allowing for analysis of diverse and unstructured data. They tend to be a strong choice for organizations with mature security operations, looking for highly customizable and powerful analytics.
So if an organization prioritizes advanced threat hunting
Right.
and the ability to analyze a wide variety of data, Splunk might be a strong contender.
Exactly.
What about some of the other major players in the market?
So another major player with a significant market share is IBM QRT.
Okay.
QRT emphasizes a more structured data approach
Mm-hmm.
and is known for its strong focus on network security analytics and its integrated threat intelligence capabilities.
Okay.
They also highlight their AI-powered threat detection features to help security teams prioritize and respond to the most critical threats. Their architecture is more focused on normalizing and correlating events within a structured database. Radar often appeals to large enterprises seeking a comprehensive and integrated security intelligence platform.
What about the major cloud providers and
Right.
their offerings?
So Microsoft Sentinel is a prime example of a cloud-native SIEM solution, being built directly on the Azure cloud platform.
Uh-huh.
Provides the inherent advantages in terms of scalability, ease of deployment, and seamless integration with other Microsoft security services,
Okay.
and the broader Azure ecosystem. Its pay-as-you-go pricing model and serverless architecture can be very appealing
Uh-huh.
for organizations heavily invested in Microsoft's cloud infrastructure. Sentinel also heavily leverages AI and machine learning
Okay.
for advanced threat detection and analytics.
Are there some other kind of established, well-regarded players in the market?
Yes, definitely. So ArcSight,
Okay.
now part of Micro Focus, has a long history in the SIEM space
Uh-huh.
and is particularly recognized for its robust event correlation engine and its strong focus on compliance and regulatory requirements. They offer both on-premises and cloud-based deployment options
Okay.
and are often chosen by organizations with complex compliance mandates. Another one is Logarithm.
Okay.
They focus on providing an integrated platform that combines some capabilities with endpoint detection and response,
Mm-hmm.
EDR,
Mm-hmm.
and security orchestration, automation, and response, SOR functionalities. They emphasize simplifying incident response
Okay.
and improving security operations efficiency.
Are there any notable open source or more budget-friendly alternatives available?
Yes, there are. So Elastic SIEM,
Okay.
built on the popular open source Elasticsearch platform, provides a compelling open and extensible SIEM solution.
Uh-huh.
Its open source nature can be attractive to organizations with budget constraints
Okay.
or those who prefer the flexibility and customization options offered by open source software.
Mm-hmm.
It offers a wide range of features
Uh-huh.
and a strong community support, and for small to medium-sized businesses
Okay.
with perhaps less mature security operations,
Sure.
Alien Vault.
Okay.
Now, part of AT&T cybersecurity is often positioned as a more unified and user-friendly platform. that integrate SIEM with other essential security tools.
So with such a diverse range of options, how should an organization approach the decision of choosing the best SIM for their needs?
The reality is there's no universally best SIEM solution.
Okay.
The ideal choice is highly dependent on an organization's specific requirement,
Uh-huh.
including their budget,
Okay.
the size and complexity of their IT environment, their specific compliance obligations, the sophistication of their security team,
Okay.
and their tolerance for managing the underlying infrastructure. As we touched on earlier, large enterprises with mature security operations and complex data analysis needs might be a better fit for platforms like Splunk or QRadar, while smaller organizations with simpler infrastructures might find Elastic SIEM or Alien Vault more appropriate. Cloud-native options like Microsoft Sentinel can be a natural fit for organizations heavily invested in those cloud ecosystems. Ultimately, it's about carefully evaluating your own unique needs
Uh-huh.
and matching them to the strengths and capabilities of the various SIEM solutions available.
Right.
It's often a good idea to conduct thorough evaluations and even proof-of-concept deployments
Mm-hmm.
to see how a particular SIEM performs in your specific environment.
That's a very pragmatic perspective.
Right.
It's clearly not a one-size-fits-all situation.
Exactly.
And careful evaluation is key.
Absolutely.
Now, we've discussed what SIEMs are,
Mhm.
how they're deployed, their internal components, how to think about sizing them,
Yep.
some of the key vendors. But how do SIEMs actually work
Right.
to detect those all-important threats? What are the underlying detection models they employ?
Right. So SIEM solutions utilize a variety of detection models
Okay.
to identify malicious activity within those vast streams of log data they collect and analyze.